AgBr solid is a pale yellow colored salt sparingly soluble in water. The solubility product of AgBr at 25 degrees is also given. Question number 1. Calculate the concentration of Ag plus ions in a saturated solution of AgBr in equilibrium with solid AgBr at 25 degrees Celsius. According to this question, there is a solution of saturated AgBr in equilibrium with solid AgBr. We need to calculate the concentration of Ag plus ions in this saturated solution. This equilibrium exists in the given saturated solution. Solid AgBr is in equilibrium with aqueous Ag plus ions and aqueous Br minus ions. If the solubility of AgBr is S moles per cubic decimeter, the concentration of Ag plus ions is S and Br minus ions also S moles per cubic decimeter. Here we assume that the solubility of AgBr is S moles per cubic decimeter. Next, we have to write the Ksp expression for the given equilibrium. Ksp equals concentration of Ag plus ions times concentration of Br minus. Next, substitute values for this expression. Solubility product of AgBr at 25 degrees is 5 times 10 to the negative 13 mole squared dm negative 6. Concentration of Ag plus ions at equilibrium is S. Then Br minus at equilibrium also S. So it's S to the power 2. S equals square root of 5 times 10 to the minus 13 moles per cubic decimeter. The answer is 7.1 times 10 to the negative 7 moles per cubic decimeter. Therefore, concentration of Ag plus ions in this saturated solution is 7.1 times 10 to the negative 7 moles per cubic decimeter. This is the answer for question number 1. Question number 2. Solid AgBr together with 100 cubic centimeters of the solution described in part 1 above were placed in a beaker. A volume of 100 cubic centimeters of distilled water was added to the beaker and the mixture was stirred well until the equilibrium is reached. At this stage, some solid AgBr was still left at the bottom of the beaker. What could be the concentration of aqueous Ag plus ions in this solution? Explain your answer. First, we will move to the initial system. 100 cubic centimeters of the solution described in part 1 above was placed in a beaker. This solid AgBr is in equilibrium with aqueous cations and aqueous anions. Therefore, this solution is a saturated solution. In saturated solutions, ionic product equals Ksp. Next, we will move to the final system. Now, 100 cubic centimeters of distilled water was added to the initial system and the mixture was stirred until the equilibrium is reached. That means the equilibrium is reached in the final system as well. Therefore, the final solution also a saturated solution. When the solid is in equilibrium with its aqueous ions, the solution is a saturated solution. In these saturated solutions, ionic product equals Ksp. The value of Ksp depends only on the temperature. As the temperature constant, the ionic product in the initial solution as well as the final solution is also the same. Therefore, concentration of Ag plus ions in the final solution is the same as the concentration of Ag plus ions in the initial solution. Ag plus ion concentration in the diluted solution is the same as previous, 7.1 times 10 to the power minus 7 moles per cubic decimeter. The explanation is this diluted solution is also a saturated solution of AgBr. Question number 3. Using suitable calculation, predict the observation expected when 10 cubic centimeters of 1.5 times 10 to the negative 4 moles per cubic decimeter silver nitrate solution and 5 cubic centimeters of 6 times 10 to the negative 4 moles per cubic decimeter sodium bromide solution are mixed at 25 degrees Celsius. Silver nitrate solution and sodium bromide solutions were mixed together during the given experiment. The ions present in silver nitrate solutions are Ag plus and NO3 minus. The ions present in NaBr solution are Na plus Br minus. Next, move to the mixture. We can see Ag plus ions, nitrate ions, Na plus ions and Br minus ions are present in the final mixture. When silver ions are present with bromide ions in a given mixture, there's a possibility of forming the silver bromide precipitate. If the ionic product of Ag plus and Br minus ions in the final mixture is less than Ksp, this solution is unsaturated and no AgBr precipitate will be formed. If the ionic product of Ag plus and Br minus in the final mixture is greater than Ksp, this solution is saturated and AgBr precipitate will be formed. Again, we will move to the question. Using a suitable calculation, predict the observation expected when these two solutions are mixed at the given temperature. Now, to get the answer, we need to find whether the ionic product is less than Ksp or the ionic product is greater than Ksp. Therefore, first we need to calculate the ionic product in the final mixture. To find the ionic product, we need the concentration of Ag plus ions and Br minus ions in the final mixture. The initial concentration of silver nitrate and the initial concentration of sodium bromide were given in the question. But when these two solutions are mixed together, final volume increases and therefore these two concentrations will be decreased because of the dilution effect. Therefore, the first thing we have to do in these type of questions is calculate the diluted concentration of Ag plus ions and the diluted concentration of Br minus ions in this mixture. C1V1 equals C2V2 gives you the concentration of the diluted solution. Therefore, C2 equals C1V1 divided by V2. Concentration of silver nitrate in the final mixture or the diluted concentration. C1 is 1.5 times 10 to the negative 4 moles per cubic decimeter. Initial volume V1 is 10 cubic centimeters. V2, the final volume is 15 cubic centimeters. Diluted concentration is 1 times 10 to the negative 4 moles per cubic decimeter. When one silver nitrate molecule dissociates, it gives 1 Ag plus. The stoichiometry is 1:1. Therefore, Ag plus concentration in the final mixture also 1 times 10 to the negative 4 moles per cubic decimeter. Concentration of NaBr in the final mixture. Initial concentration 6 times 10 to the negative 4 moles per cubic decimeter. V1, the initial volume is 5 cubic centimeter. Final volume 15 cubic centimeter. Therefore, the diluted concentration is 2 times 10 to the negative 4 moles per cubic decimeter. Sodium bromide. One molecule gives one bromide ion. The stoichiometry between NaBr and Br minus is 1:1. Therefore, Br minus concentration in the final mixture or the diluted mixture is also the same as the concentration of NaBr. Ionic product in the final solution can be calculated using the concentration of Ag plus ions and Br minus ions in the final mixture. Concentration of Ag plus ion is 1 times 10 to the negative 4 moles per cubic decimeter times concentration of Br minus in the diluted mixture 2 times 10 to the negative 4 moles per cubic decimeter. The ionic product at the given temperature is 2 times 10 to the negative 8 mole squared dm negative 6. At 25 degrees Celsius, Ksp of AgBr is 5 times 10 to the negative 13. Ionic product of AgBr is 2 times 10 to the negative 8. At 25 degrees Celsius, ionic product is greater than Ksp. Therefore, pale yellow color AgBr precipitate will form in the final mixture. This is the answer for the question number 3.